So there is a video to what we're about to do. So what we're going to do is to kind of do something you've probably done before, which is basically create a key to how you would factor. Um, the first part of factoring, we're going to take it in steps. All right. The first part of factoring is to figure out what your greatest common factor is. If it's 1, then you move on to step 2. And that's where you figure out how many terms you're dealing with. And then you figure out if you're dealing with certain types of signs. So what we're going to do, first we're going to factor out a greatest common factor. So you have to show your work. Showing your work here when you're just simply factoring out the greatest common factor is that you swing out your factor, you swing out your GCF to the top and the bottom, like we did before with the rationals. And then you're going to take the GCF and you're going to divide it out of each individual term. Okay, so like I would have 5x cubed divided by the GCF, close parentheses. I would have negative 15, sorry. So our GCF is going to be way out here. So let me rewrite that. Let me do that over a little bit. So parentheses, first term 5x cubed divided by our GCF. Keep it parentheses open. Keep them open. Negative 15x squared divided by the GCF plus 5x divided by the GCF. So we're going to make sure that we're going to go find out what the GCF is. So for numbers, we're dealing with two numbers. We're dealing with 5 and 15. And so we would go to math, right arrow over to num, type 5, 15, close the parentheses, press enter, and you'll find that your GCF is in fact 5 over 5. So you would literally write 5 over 5 parentheses here, and then come back and replace the tops and bottoms of each term, under each term. So 5 out here equals 5, and I divide each term by 5, right? Simplified, I'm going to write my answer over here. This equals 5 parentheses. I'm not finished. Now the other part of my GCF is the smallest variable here. So that's going to be x on the top, x on the bottom. So just making sure I divide that out of both terms. And I'm going to do one more before I move on. I have 5x times 5 divided by 5 is 1. X cubed divided by x is x squared, plus 15 divided by 5 is 3. And it's negative 3. That's a negative 3. So negative 3. X squared, take away 1 from the bottom, I'm left with 1x on the top, plus 5 divided by 5 is 1, and that's 1, and you're done. Okay? So another example of greatest common factor if you're still stuck. So let's take 10x cubed plus 100xy. Well, if you put your numbers in the graphing calculator, you know the greatest number I can divide out of both numbers is going to be 10. So 10 on the top and 10 on the bottom. For your variables, the smallest variable I have here, there's two x's. There's an x cubed and there's an x. The smaller of the two is x, so I divide that out. For y, there is not a y in both terms, so I can't do anything there. Now, the original expression is 10x cubed plus 100 xy. So when you're supplying your answer here, you need to write out the greatest common factor, times, parentheses, the original expression. And then you go back and divide the greatest common factor from the individual terms. So I have 10x, so this goes inside and divides out from the individual terms. 10x times 10x, the quantity of 10x cubed, divided by 10x plus 100 xy divided by 10x. This equals 10x. 10 divided by 10 is just 1. X cubed minus 1 from the bottom. I'm left with x squared on the top, plus, looking at my next term, 100 divided by 10 is 10. X divided by x goes away, and y, I'm just left with y. And here is the factored answer for that particular polynomial. Okay? Now, that's the work that you should show for factoring the greatest common factor. When you're factoring next, when you're looking at your polynomial, you ask yourself how many terms are in the given polynomial. If there are 2 terms, there's 3 possible things that you could be doing. There's 3 possible things that you could be doing. You could be working with the difference of 2 squares, and you'll realize this because you'll see the 2 squares. So the formula for difference of 2 squares is x squared. Sorry, that's not what I want to write. Your first term, we'll call it a squared minus b squared. So you have 2 terms, and what that ends up equaling is, I'm just going to write the formula here, a plus b times the quantity of a minus b. So how do you get a? How do you get a? You take the square root of a squared, this equals a. You take the square root of b squared, this equals b. All right? So for the first term, I'm going to show you how to work it out. First expression, I have x squared minus 49. So I'm going to take the square root of x squared, this equals x. And then this is my a. Take the square root of 49, this equals 7. Okay? So it equals plus or minus 7. So when I write, this is your b. This is your b. So when I write this out, I have x squared minus 49 equals x plus 7 times x minus 7. Now, if I'm factoring the difference of 2 cubes, the formula for that, what it looks like is a cubed minus b cubed equals a plus b times a squared minus ab plus b squared. So, how do I find a? How do I find b? Well, let's take the cube root of your first term. So I have the cube root of 8x cubed. Well, the cube root of 8 is 2, and the cube root of x cubed is just x. And then I need the square of this term. So 2x squared, this equals 2 squared, or 4, and then x squared. So because I need I need a, and then I need a squared. Okay? Now, for b, I need the cube root of b. b is 1. So the cube root of 1, equals 1. Now, 1 squared equals 1. So these are all the things that you need to write out. And I'll do it formally in a different problem. So when I'm writing this out, I have my original expression, 8x cubed minus 1 equals 2x plus 1 times 4x squared minus 2x times 1, or minus 2x, plus b squared, or 1. Okay? And that's my final answer. This is your answer. This is the factored form of this cubic function. Now, typically, you want to make sure it's fully factored, so you would try to factor this quadratic, but we don't have to do that. Next problem, sum of two cubes. I have a cubed plus b cubed. And the formula for that, you have a cubed plus b cubed equals a minus b times a squared plus ab plus b squared. Okay? Now, I take the cube root of the first part, so the cube root of 8x cubed equals 2x, and then I square this, square what a is. 2 squared is 4, x squared is just x squared. Next, I take the cube root of 1, this equals 1, 1 squared equals 1. Now, from writing this out appropriately, I have ax cubed plus 1, this equals starting off, a minus b, or 2x minus 1 times the quantity of 4x squared plus 2x plus 1. And there is your sum of two cubes. Now, so what if you're dealing with 3 terms, trinomials with leading coefficients? Part of what you're going to have to do is to create a table. You're going to have to identify some numbers here. You have ax squared in general plus bx plus c. So what you're looking for, your numbers here, the number in front of a is 1, the number in front of b is 1, and the number in front of c is -6. So what we're looking for is two numbers that multiply. They multiply to -6, and they add up to +1. They add up to +1. So that means the bigger number has to be positive. Okay, if this number is positive, the bigger number has to be positive. So two numbers that add up to +1. We have 3 and -2. We have 6 and -1. And I think that's it. So 3 minus 2 is +1. 6 minus 1 is +5. So it can't be this one. So my two factors, when I write this out, x squared plus x minus 6 equals x plus 1 times the quantity of x, I'm sorry, we said the factor was -2, and 3. So parentheses x minus 2 times x plus 3. And that's it. That's all you have to do. Now, when you have a trinomial where the leading coefficient is greater than 1, first you're going to have to slide and divide to get a 1 in front of that x squared term, and then you're going to have to factor it out, so creating that factor table, and then you're going to have to divide the number you factored out. So first, sliding and dividing, I bring the 6 over. I get x squared plus 11x minus 10 times 6. So this is x squared plus 11x minus 60. Looking for two numbers, I create my table, multiply to negative 60. They add up to a positive number 11. So my bigger number is positive, my smaller number is negative. So starting with 1 and negative 1 is 60, I get 59. 60 minus 1 is 59. Starting with 2, negative 2, and 30. 30 minus 2 is negative 28, so that's not it. 3 is a factor, so negative 3 and 20. 20 minus 3 is positive 17. That doesn't work. We'll try negative 4 and positive 15. 15 minus 4 is positive 11. Those are my factors here. So I get my factors and factor out x plus 15 times x minus 4. And then I come back and divide out the number that I originally multiplied by from each number on the bottom. I get x plus 3, 15 over 5 is 3, times the quantity of x minus 4 over 5. And there's my final answer. Now, the last thing we want to do is grouping. This is when we have 4 individual terms. So we always group our 2 biggest terms together, and we're going to factor out the greatest common factor, and our 2 smallest terms go together. So for the 2 biggest terms, the biggest number I can divide out is 1, so I'm not going to put a number out front. So I have, looking at my x's, I have x cubed and x squared. We always factor out the biggest variable term, the smallest variable term, and we write our expression. Okay, and then for the other side, I have numbers that I'm factoring out. Both are negative, so I'm going to factor out a negative. Greatest common factor between 3 and 6, the biggest number I can divide out of 3, and the biggest number I can divide out of 6 is 3, so 3 over 3. Since I only have one variable x, there are no variables coming out as a part of the greatest common factor. So what I'm left with inside is negative 3x minus 6. Now, part by part, x squared stays outside on the top, and the inside x cubed over x squared plus 2x squared over x squared. Keep moving. Minus 3 times negative 3x divided by negative 3 minus 6 divided by negative 3. All right, we're going to simplify. Okay, we have x squared. On the inside, I simplify and I get x cubed divided by x squared. So it's like subtracting 2 at the top, and I'm left with x to the 1 power plus 2 just drops down. X squared minus x divided by x squared just goes away. Over here, I have minus 3 parentheses on the inside. Negative 3 divided by negative 3 is just x. Minus 6 divided by negative 3 is positive 2. Now, if you look, you have two factors that are the same. If you recall, what we do is we bring down one of these, one goes away, and then we place these two quantities together. It's like a reverse distribution almost. So x squared, this is why it's called grouping, because we're grouping two terms together, and one of these goes away, and I'm left with x plus 2 because they are the same. And this is the final answer. Now, if I wanted to factor this further, I could use the difference of two squares. But that's all I have for you for that particular section. I'll make one more video to show you how I want you to present the work for each individual type of problem, just in case. All right, have a great day. Sorry, I'm not going to present a video. I'm going to pass along a worksheet for you to show you how to create your project. Have a great day.